Welcome to Pindar Poetry. We hope you learned something new.
You start by setting exact definitions, what SFL means versus WFL in this problem, and why each matters to your goals. Once defined, gather clean input. Nodes, weights, capacities, and any constraints make sure formats match, otherwise your results will be wrong. Next, pick a calculation tool, spreadsheet for small sets, Python plus a graph library for larger ones, because the right tool speeds searches and reduces mistakes. Now you're ready to compute. You perform the core computation. Run a shortest path or minimal cost search to generate candidate SFLs, since SFL is the minimal feasible length under constraints. Once you have candidates, apply constraints explicitly, capacity, time windows, band nodes, and filter out infeasible ones. Then validate by simulating or backchecking resource usage along the chosen path, because a short path that violates constraints is useless. If multiple candidates tie, choose by secondary metric like latency or cost. You now locate WFL by searching for the maximal feasible route or configuration that still meets constraints, using breadth first or constrained optimization with an objective to maximize length. Once you have SFL and WFL, compute the gap and percentage difference so you understand variability and risk. Finally, document assumptions, parameters, and run one reproducible validation to prove both results. Troubleshooting tip: if results
Thanks for watching. Consider subscribing if we helped you.